In this video, I'm going to talk about image formation by concave mirrors. We're going to place an object in front of a concave mirror at different points, and we're going to find out where we will get the image. Before drawing the ray diagrams, we need to know where we should place the object. Okay, so I'm going to make a small table. The first column is about object position. That is XO. X is for position, O is for object, XO. And the second column is the image position. XI, I for image. Okay, let's find the object position. So I have a concave mirror here, and this is the principal axis. This is focal point. This is center of curvature. I'm going to place an object far from the mirror. So let's call it infinity. At infinity. That's my first position, at infinity. Okay, now I'm going to move this object. I'm going to move it closer to the mirror. I'm going to place it behind C or beyond C. Okay, so that's my next position, beyond C. Okay, let's move it again. Now the next position will be at C. At C. Okay, moving it again. Placing it between C and F. Between C and F. Okay. Moving it to the focal point. That's my next point. At F. There's one more point where you can place it. It's between focal point and the pole of the mirror. So I'm going to place it here. This is the pole. M. Okay, I'm going to write it separately. You'll know why by the end of this video. Between F and M. M is the pole. You can also use P. Yeah. So we got all the object positions, and we are going to find out the image positions by drawing the ray diagrams. Let's start with object at infinity. So this is a concave mirror. I'm going to draw the principal axis. Okay, that's my principal axis. Take a ruler, make sure 0 is at P pole. We start from the pole. For concave mirror, we're going to go left, because center of curvature, focal point, everything is on the left hand side for a concave mirror. Yeah, so let's mark it. So focal point at 5 centimeter, and center of curvature should be double the focal length, so 10 centimeter. You can take any distance, it's totally fine. Just make sure center of curvature is 2 times the focal length. This is M, the pole, this is F, focal point, and this is center of curvature. You can mark focal point at any distance from the pole, it's totally fine. Let's say 5 centimeter. FM is 5 centimeter, so CF should be 5 centimeter. F should be the midpoint of CM, the radius of curvature. Let's say you're taking focal length as 3 centimeter, distance FM is 3 centimeter, then CF should be 3 centimeter. Totally 6, F is the midpoint. Alternatively, you can count the number of squares. So M is here. Now let's count the number of squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. F is 9 squares away from M. So C should be 9 squares away from F. So 9 squares. So let's count from here. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 squares as well. If FM is 10 squares, make sure CF is also 10 squares. I'm going to place the object at infinity, far from the mirror. That's my object. You can represent the object using an arrow. I'm going to draw the light rays now. We need to draw at least 2 light rays. So I'm going to draw the first one. Okay, that's my incident ray. It's coming parallel to the principal axis. In fact, if you place an object at the infinity, all the rays are parallel to the principal axis. All the incoming rays are parallel to the principal axis. Okay, so rule number 1, if a light ray comes in parallel to the principal axis, after reflection, it would pass through the focal point. That's the story of the first ray. Now, I'm going to draw the second light ray. Okay, again, parallel to the principal axis. So it would pass through the focal point. So these 2 light rays intersect at the focal point. Let's draw 2 more light rays. Okay, see what happens. That's the third one. It's coming parallel to the principal axis, pass through the focal point. One more. Yeah, all these light rays intersect exactly at the focal point. So an image will be formed at the focal point. Now the nature of the image, it's highly diminished, very small. You can barely see it. The image is formed in front of the mirror. This is the mirror. This is the reflective surface. So this is the front side of the mirror. This is the front side of the mirror. And the image is formed in front of the mirror. So it's a real image. Real. But it's inverted. In this case, you cannot really see it, but it's inverted. The image is inverted. Upside down. Yeah. Second one, object beyond C. I'm going to place an object just behind C. That's my object. I'm going to draw the light rays. We need at least 2 light rays. So this is the first one. It's parallel to the principal axis. And after reflection, it should go through the focal point. We need 1 more. Okay. The second one, the incident ray comes in through the focal point. After reflection, the reflected ray should be parallel to the principal axis. These 2 light rays intersect at this point. So an image would be formed here. We use dotted lines to represent an image. An image is formed between C and F. This is the center of curvature. This is the focal point. We got an image between them. Yeah, so if you place an object beyond C, the image would be formed between C and F. Now, what about the nature of the image? It's inverted because the 2 lines intersect below the x-axis or the principal axis. So it's inverted. It's a real image because we got the image in front of the mirror. This is the front side of the mirror. This is the back side because this is the reflective surface, right? Yeah. Okay, so it's real and inverted. What about the size of the image? Okay, let's count the squares. So the object is 1, 2, 3, 4 squares up. The image is just 3 squares, 3 and a bit. Yeah, so it's slightly shorter. So that's a diminished image. Diminished. Again, you don't need to draw the same 2 light rays. You can also draw like this. So that's my mirror. That's the principal axis. That's the focal point. That's the center of curvature. Place an object here. Yeah, that's beyond C. First light ray goes parallel. After reflection, should go through the focal point. Second light ray, you can draw the light ray through the center of curvature. That's another possibility. Okay, I need to extend this side of the mirror. Yeah. Okay. if a light ray comes in through the center of curvature, after reflection, the reflected ray would go back through the center of curvature, through the same path. It takes a 180-degree U-turn. Again, these two rays intersect between C and F. So an image is formed here. It's an inverted image, smaller than the object, because you got the same answer. Third case, so we placed an object at the infinity, then beyond C. Now I'm going to place it at C, at the center of curvature. Let's draw the light rays. The first light ray goes in parallel to the principal axis. After reflection, it should go through the focal point. Okay, the second light ray, it cannot draw the second light ray through the center of curvature because the object is placed at the center of curvature. So the second light ray, I'm going to draw it through the focal point. The rule is, if a light ray comes in through the focal point, it should reflect back parallel to the principal axis. At C, almost at C. Yeah, that minute difference is because of the error in my measurements. If you place an object at C, you should get an image at C. An image is formed at C. What about the nature of the image? It's inverted. It's below the principal axis. And it's real as well. The image is formed in front of the mirror. Real and inverted. What about the size? Count the squares. 1, 2, 3, 4. Object is 4 squares up. Image is 1, 2, 3, 4. 4 squares down. So same size. Same size. Next case is about placing an object between C and F. That's my object. So I'm going to draw the first light ray parallel to the principal axis. That light ray should reflect back through the focal point. The second light ray, I can draw it through the focal point. It should go parallel to the principal axis after reflection. These two lines intersect here beyond C. I'm going to extend this principal axis a bit. That's our image. An image is formed beyond C. Okay, again the image is formed in front of the mirror. This is the reflective surface. So this is the front side of the mirror. An image is formed here. So it's a real image and it's inverted because it's below the principal axis. So real and inverted. Now what about the size? Our object is 3 squares up, 1, 2, 3. But our image is 1, 2, 3, 4, 5. 5 squares down. Enlarged. We got an enlarged image. Enlarged. Next case, object at the focal point. That's my object. The first light ray goes parallel to the principal axis. After reflection, it should go through the focal point. The second light ray, again, you cannot draw it through the focal point because the object is placed at the focal point. There are two possibilities. You can either draw a light ray that comes in through the center of curvature. Draw a light ray connecting these 2 points. After reflection, it should go back through the center of curvature. Yeah, so these are the 2 light rays. Yeah, but they are parallel lines. They're never going to intersect. So no image will be formed. No image in this case. Or you could say an image will be formed at infinity, but you're not going to get an image. Because there is no image, you can't define the nature of the image or the size of the image. Another possibility is you can draw a light ray that hits the pole at an angle. It should reflect back at the same angle. Again, all the 3 light rays are parallel to each other. So they're not going to intersect at any point, so image will not be formed. The last case, I'm going to place an object between F and M. Object between the focal point and the pole, and the mirror. M is the pole. The first light ray, it hits the pole directly at an angle, so it should reflect at the same angle. That's the reflected light ray. Now, how do we draw the second light ray? Okay, we can draw one that comes in through the center of curvature. I'm going to connect center of curvature and the top of the object. Yeah, that's the light ray comes in through the center of curvature. After reflection, should go back through the center of curvature. All right, now these two light rays are not parallel. They're not parallel to each other, but they're not going to intersect in front of the mirror. This is the front side of the mirror, right? Because this is the reflective surface, and they're not going to intersect anywhere in front of the mirror. They're diverging, right? If you extend these two light rays towards the back side of the mirror, they're going to intersect somewhere behind the mirror, right? Yeah, so I'm going to do that. We're talking about behind the mirror. That doesn't exist. That's why I'm using dotted lines. Our image is formed here. It's above the principal axis. So that's our image. So we got the image behind the mirror. Image is formed behind the mirror. What about the nature of the image? It's not real. It's virtual, because the image is formed behind the mirror. The images formed behind the mirror are always virtual. They're not real. So it's a virtual image. It's not inverted anymore. It's upright. This is the only image formed by a concave mirror that is virtual and upright. If you place the object between F and M, focal point and the pole. What about the size of the image? It's enlarged. Our object is just 2 squares up, but the image is 1, 2, 3, 4, 5 squares up. So that's enlarged. This is the reason why you can use a concave mirror as a shaving mirror, because the object has to be really, really close to the mirror for an image to be formed, and the formed image is enlarged. It's magnified. All right, so we got all the images. We know the image positions. We are going to complete this table. So if you place an object at infinity, an image would be formed at the focal point at F. Now if you place an object beyond C, an image will be formed between C and F. If you place the object at C, image is formed at C. If you place an object between C and F, image is formed beyond C. If you place an object at F, technically the image should not be formed, but you could say it's formed at infinity, somewhere at infinity. So you could write at infinity, or let's say no image. So our image position till the focal point, the first 5 cases, it's in the reverse order of the object position, right? At infinity, we started with at infinity. The last one is at infinity or no image. Then beyond C, at C, between C and F, and at F, right? So that's the shortcut to memorize it. Now the last one, between F and M, image will be formed behind the mirror. That's the only exception. Behind the mirror. Now the nature of the image, the first 5 are all real images. They are inverted as well. The last one is virtual and upright. That's all about the image formation by concave mirrors. In the next video, we'll talk about image formation by convex mirrors.